Hi all. Today we will be going through system Verilog integer data type. So normally in system Verilog we will be having multiple integers like int is there, integer is there, and short int, long int. These are the main four long integers, short integer, integer, and int. So now before going to the difference between int and integer, let's understand what all why we will be when we will be using int and integer. Let's say if you have a data that has a two-state data type, during that time we will be declaring int, like int is a two-state data type, and in the same way integer is for four-state data type. So now by default two-state data type value will be 0, and default value for integer or a four-state data type will be x. So here let's make this is the default. So now let's understand with the some graph and all, like why it is declared with int and integer, like usage. So let's say I'll be having a model tb and n model. So let's consider a variable int I underscore int and integer I underscore integer. And also now to print anything I'll be using inside initial, begin, and end. Let's see how we can print the data, and we can analyze with the waveform as well. Now let's say I will be using this dollar display sorry value of I underscore int is, as we know that integer should be declared with %d, and I underscore integer equals to %d. Let's add the first %d int and the next I underscore integer. So just save this file. Okay, before that it is asking select the simulator. Normally we will be having many simulators. I used to prefer synopsis, and let's run this one. Check whether any compilation errors are there. See, so the value of I underscore int and integer is x, like whatever the values will be there defined for int and integer, it will be displayed. Now if you see I underscore int, after that we have so many gaps, like why it is so. Now understand usage of this %0d. See, if you see here, like here the display is I underscore int equals to 0 and integer is x. So here I have the space, I will remove that space also. See, whenever we write some sequences and all, normally we will be giving this %0d, like for a clear understanding. If I don't give that 0, like it will take, as we know that okay, maybe I will add int is 32-bit data type, and even integer is also 32-bit data type. So what will happen is, if you don't use this 0 in, so it will create a memory which will be having 32-bit data. So that will be the case. Now sometimes we don't need all 32 bits, we may use just a 32 bit meaning just int 234. During that time we can assign. Now if you see the initial value, now let's generate one random variable like a random data. We will be going to this random and dollar random. Let's declare this random, and now same let's give some prints understanding before assigning value of this one, after assigning. Let's see what the random data is generated. See, after before value is 0 and x for int and integer, and after assigning, meaning after using this dollar random value, the random 32-bit data will be generated. Here if you see corresponding, this data is in decimal which has a 4. Now let's say if I want to do some, like normally these are the, like where if I say here the negative sign, so like these are the signed 32-bit data. So signed means it may have positive as well as a negative numbers. Now let's add some waves, like add waveform, like we'll be using dump variables. Just copy the initial begin. So one second, I can add just copy, paste it. And after some times I will be calling this dollar finish. So what will happen is after 300 simulation time, this dollar finish will call and the simulation gets over. Let's see. Okay, so here see we have here open wave, open EP wave after run. So see here I can see that simulation is finished at 300 nanosecond. One more thing, like here precision is there, like 1 nanosecond by 1 nanosecond, meaning our simulations will be running in 1 nanosecond, not in 1 nanosecond, meaning it will be running in nanosecond, and the precision will be 1 nanosecond by 1 nanosecond. So we will go through with those also later part. See here the values got generated. If you want to take that both, here it is 32-bit I underscore int, and I underscore integer is also 32-bit data. So you can see here like 0 to 31. And now let's select this hexa. Okay, already it is a hexa. Now if I go to, if we want to see the values on waveform, let's assign some delay so that it will be generating. Let's give some 30 delay. now we should be able to see the value, like initially whatever the values are there, like it will be 30 nanosecond, and now after 30 nanosecond we are generated and this repeat data. And now to see the value on the waveform, let's add some, repeat this 20 times and begin, and one more end. So now what will happen is it will run for 20 times. Okay, what is happening here is it is generating until 30 nanosecond, but as per waveform it is taking, but the values, 20 values got generated. Okay, see here I can see that some positive numbers are there and even some negative numbers are there. If you closely see here, if the values are plus and the next values, like we are generating the random numbers. So now the issue here is why the values, meaning it got generated. Okay, this initial begin is taken for 30 millisecond, sorry 30 nanosecond, that's why this got executed. So what we need to, okay, let's see, I will add one more hash to see the values. I just want to see, later we can analyze why it is not showing 300 nanosecond. See here, if I now I can able to see the values, like initially it is changing from initially as per wave code, like we have given this 30, the values will be 0 and x corresponding values, and after that the values got changed. So with this we can say that our initial begin, this loop is taking 30 plus 20 into 10, 200, so 200 plus 30, it should be giving 230 here. See, 218 and here 220. Okay, so now I can see only this begin and end 200. So this is the way what we can analyze this. See here we can see the values. So now coming to the questions, like during interviews what they can ask is, like why don't we use inside like outside this display. Let's say if dollar display, I'm considering one example. So just print for display. See what will happen if I use this dollar, meaning this system Verilog methods outside the initial begin. So we will be, let's see what kind of error we will be getting. See what it is saying is only elaboration system task allowed here. So it means that whenever we want to use something task related, we should be always adding inside the initial begin. This is one point what we noted down. And another point is the use of this percentage 0d, like that gives a clear understanding in the sense we can able to like see the what is the value generated. If like normally in industry we will be having lakhs of lines, so with that what will happen is we are not able to map, like when we have the complex debugs. Let's say I will just remove this. Now I can see that value of I integer easily. Now if I remove that 0 in the just I underscore int, so here what is happening is it is taking full 32-bit value, like it anyway it has generated this random value, but sometimes like if I add some dollar random, let's say I will add this random range between 40 to 60, we will go through this dollar functions. I just wanted to show how the logs dollar rand is not sorry. So dollar random range and u random range is not defined. See here the values are not proper. So this is the one thing we can use. Now coming to the this delays and like here it has repeated for 20 times with begin and end. This is one loops and all will go through the later part. So my basic intention here is to show like default values for int and integer. Yeah, this is all about the int and integer, and in the next coming video we will be going through the short int and long int.